All right, so today we're going to continue working on our reaction project. So just a quick recap here. Last Sunday we worked on this by no, first let's just go over what this is real quick. So the plan is to make a small little system that we can use to easily tag screenshots and pictures or files on our computer with tags that mean something to us. Specifically, you know, we're kind of talking about like when you respond to people online, a lot of time we use the images to do that. And people accumulate a lot of these images over time, and it kind of becomes hard to find them. So it'd be nice if we could organize these and apply metadata to them. So that's what we started working on. Last time we worked on the directory configuration, and that and our domain models are what we got through. So we're using the Play framework version 2.3. And last time, just to quickly go over this to recap, we made our domain objects. So we have a file that can be tagged or queued, origins of the files, as well as the tags that can be applied to them. And then we set it up so that we could have a directory configuration, which tells the system which ones to scan, which ones to ignore, and whether or not for each of these configuration or configured directories, whether or not it should recurse into them when it traverses the directory tree. And that's where we got, and we wrote tests and they all pass, right? So today the plan is to put down some more foundational work, which is the database work. So we're going to be using SQLite because it's one of those easier things to embed. And to accomplish this, we're going to be using two things that I already have open in a tab. We're going to use the Hikari connection pool plugin for Play 2.3 because Hikari CP is it's a good library. You can read all about why it's good on his GitHub. I won't bother you with that, but basically it's very stable and has a very thoroughly tested source. And so there's this guy who's made a plugin for 2.3, and then we're going to be using anorm because that's what comes with 2.3 in Play. It's also I prefer it over Slick personally because it's a little bit easier to reason about, and it lets you write SQL, and I like to write my SQL in SQL, so you know, nothing too crazy there. So with that said, let's get started on this. So first off, we're going to need to bring in the plugin. And also, let's just make sure, yeah, my voice is higher than the background noise. Okay. So, so for version Play 2.3, and I don't know which version we're using, but looks like 2.3 will be 2.1 for this. So we'll bring that in somewhere around here. I know I saw it. Yeah. Okay. So we need to add a resolver to our build configuration. Nothing too special about that, really. And then here's our dependency, and that one's already set to 2.1, which is what we want. So great. And so we'll bring that in. Okay. Then we have to disable our DB plugin, so the bone CP doesn't work. So we'll apply that to our application.conf. And we'll note that we're going to be avoiding this because we're using Hikari CP plugin. Okay, we'll save that. Save that, close it, save that, close it, and then Play 2.3 still uses plugins. 2.4 switched to modules and deprecated them, but since we're still here and we're doing this, so we need to make a play.plugins file, and we need to spell it right. And then we'll add this in. Okay, ta-da, ta-da. And now we need to reload. And, ooh. Excuse me. And that would take a moment, but we're good. And then finally, we need to do this business here. So we'll just use the defaults for now. We're not going to worry too much about it. So this goes into application.conf, like it says. And we're not using Postgres. We're going to be using SQLite, which I could have sworn there was a table around here somewhere. It might be on the other tab. Yeah, might be on this tab. Let's take a look. Here it is, the JDBC mapping. Sweet, there it is. Nope, no, I could have sworn it was on this page, but maybe not. It might have been on the Hikari CP page. Let's go to Hikari. There we go. And am I right? Is this it? Yes, here we go. So for SQLite, we need the serial driver, I guess. So the data source class is this. So believe, I'm not really sure. I've never had to actually set up a SQLite one here. So, you know, kind of is a question here. Let's just search for connection URL for SQLite. I never use SQLite. Serial. Wait, there it is. So this is what Hikari is using from the looks of it. So that is the driver class. So that's what we'll be using. And then, yep, that, and then, come on, scroll that for me, please. JDBC SQLite. Okay. So that's what we'll be using, like that. And, believe that's sample.db, yeah. So we're going to be using reaction.db. That's what we'll call it. We don't really have a username or password, so I don't really know about that. Like I said, yeah, I don't really know. Yeah, it's not even supported, so no need, please and thank you. Okay, so theoretically, that should allow me to do some stuff. And so, theoretically, you know, this will work. So let's go ahead. I don't think I need to actually reload, but we'll do it anyway. Let's just try to do this. So we'll hop into our console. And then we'll start up an application inside of it. And then, I forgot to add these. So I forgot to add the enorm and JDBC plugin here. So I need to do that. So save that. Can't believe I forgot to do that. It's like one of those things that normally comes. I suppose I normally just copy over my my build stuff. But anyway. So I'll go to a console, and if that loads, we'll be happy. Oh, I accidentally hit a button there. There we go. Anyway, so we're gonna just start up a play application in the console. Which I'm pretty sure I can do by just instantiating an application and calling play.start on it. But, you know, Just refreshing our memory here. Okay. And so I just want to see if it will work or if I need to fiddle a bit. So let's import some play stuff. And then let's have an app. Forget, is there just default application? It needs a mode, sources, some other stuff. I think that it actually has defaults for pretty much everything except this. So we'll just start it here. Oh no, it's not going to be heavy. That's weird. For some reason, I have this vague memory of being able to start this stuff without having to deal with things. Yeah. Okay. Well, you're mean. Class of sources. Yeah. See, all this stuff is the things that I don't want to deal with. That's not even close to what I want. Nope. Nope. Yep. This bit. A static application. Really? Does that exist in 2.3? That's for that. That's for that. Application loadings. Womp, womp, womp. Do you have any pages for 2.3? Nope. Alright, then we'll figure it out ourselves then. Alright, so let's go ahead and look around. Fake application, static. Oh, it's in core. Alright, I think that's what I want. No, please. I'm just looking in the wrong place, that's all. Okay, so let's try this again, because all I want is just to run this stuff. There we go. What's your problem? Alright. Class not found. Org.sqlite. I am probably missing a dependency. So database 0 not present. You'll use this. Okay, that's fine. Yeah. Okay. So we're missing that, which means that I am probably just missing a dependency, which is fine. I probably need to include this. Are you on Maven somewhere, my friend? Listed. There we go. Right. Easy enough. So, and we need SQLite JDBC, and the version. I don't know what version it is. Bleh. Oh, not really what I wanted. Search Maven. Hi, how you doing? Or something. Zerial. There you are. Look at that. There we go. Alright, 3.2.1 sounds like the latest version here. So we'll go ahead and snag that. Okay, so let's find out. Oops. Okay, that's fine. So reload, please. Now that should have put the serial onto our class path. And assuming that there's no strange and exciting things going on for versions and whatnot, because it's probably just a provided thing, then this should be fine. So we'll wait for the download to happen here, and we'll start to think about these things. Okay, here we go. So let's import play core, and then let's ask it to make an app. There we go. We've registered a database and whatnot, so that's fine. There we go. Play application started in prod mode. Exciting. And so let's just make it implicit, because that's what we know it will need to be. Okay, so we now have an implicit app. So now we can do a little bit of testing. Specifically, we can do this business. So let's import a norm and what's this, shift ins in Windows? Yep. And now we should be able to do stuff like this. Now, granted, I obviously have no database, so this should prove interesting. So let's say I have a database with connection. We'll probably be doing transaction here. So with the transaction, we have an implicit connection, which is what C is for. We have some result. So let's just, oh, I don't know. Let's create a database. Actually, in SQLite, do you even have a concept of different databases? Or is it just the one that you connect to? I have no idea. Banana. Let's see here. We'll see how badly I messed this up. Alright, I do not have an implicit application scope. That is a lie. I totally do right here. You meanie face. I guess it's because it's static, maybe. Well, anyway. Play.current. And let's try this thing that's going to fail again. Bam! Explosions. Alright, what kind of explosions we got? Syntax error. Huh. Okay. I mean, that's not what I expected. I guess it doesn't like the semicolon. Explosions. I just want to know. SQL error missing database. Dear database. See, like I said, I don't use SQLite ever. So it's one of those things that I need to fool around with. So SQL error or a missing database. Okay, well, you know, that's fine. Just curious about this stuff. We're going to probably be using flyway to do database migrations. Though technically play does have evolutions, is what they call it, and I have never actually used them, weirdly enough. I don't even know. Error or missing database. I just told you to create a table. No idea, man. Oh, whoa, whoa. Whoa. Oh, that's why. I just forgot that this keyboard has the slash right there. Could you pretend to do what I want to do? I know it's not actually a very good statement, but it's interesting. Anyway, it is attempting to talk to things, though. So there's that. Alright, most importantly, we're going to ask it to stop the application first, just so that when we quit out of the console, we'll actually quit. Okay, so besides the fact that I don't totally know how to deal with SQLite, having never used it, we're going to continue on with our lives. So we're going to be using flyway. And flyway is a great little thing. Where you just migrate your schema, and it's great in all ways. There's a plugin for SBT that we could use, and then we can run we can run flyway migrate and flyway clean from our SBT console, which is pretty useful. So we're going to do that. And so you would go to Flyway's website and learn about how to deal with it here if you wanted to. But for my purposes, come on, we're just going to use one of my other projects that has done this before. So in project, there's plugins, and here you can see we've included the plugin, a new resolver for flyway and a flyway guy. So we'll go ahead and we will update our plugins to SBT. Oh wait, we've already done this. We're so thoughtful. I forgot that I copied that over before. So that just means that I only actually have to deal with it in here. So we actually already have flyway, the plugin, installed. See, here's all the stuff. But we do need to configure it. Specifically, we need to tell it where to look for migrations, which is going to be this. Now we're just going to make a flyway.sbt. We're going to tell it which driver to use, and that is going to be this guy. We're going to have it be using that because we're going to be talking to that guy. And then I believe we need, we're going to need to provide these, which unfortunately the annoying thing is that we have to pull in our configuration, which is kind of annoying, to be honest, but it happens. So at the top, because all imports for SBT scripts go at the top, we had to import the typesafe config, because that's what we're using here when we say config factory, and parse it and whatnot to get our URLs and things. So there, actually, now that I think about it, SQLite doesn't have a user, does it? So we're not going to need it for that, but we are going to need it for this. So default db.default.jdbc URL going there. So we'll just drop the flyway user and let it be defaulted to whatever, and call that a day there. Yeah, and we'll put our migrations into a folder in here under db. Actually, let's make this one step easier. Migrations, and then we'll call it like this. Okay, so now we'll reload because we changed SBT files, therefore we should reload. We'll make sure that it actually works, and then we'll run flyway migrate, even though we have no migrations yet, just to see. So SQLite does not support same schema, blah blah blah. Do this. All right, so we have set up this business, which is good. Great. Okay, so let's make a migration. So a migration, if you're not familiar with, is just a SQL file. That's all it is. And so for our first SQL file, we're gonna create the tables for the tag and the files and everything like that. So looking at these, right? File origin is easy. It's going to be its own table, right? No problems there at all. File tag, also its own table. Very simple. No problem at all. The files we had to think about, though, the abstract file and the tagged and queued file, because we could technically, maybe perhaps, put these into a single table. excuse me, just taking a drink. We could put these into a single table if we wanted to, with a nullable field for the instance, and a single name for the path, and then a Boolean property for whether it's tagged or not. Actually, that is tagged thing, doesn't have anything to do with that, but I mean, it could be used as a discriminator value. And then, of course, we have an ID. The other thing, though, is that if we put it into two separate tables, it becomes very easy to get a count of how many we have queued, and also to, you know, kind of drain one table into the other and things like that. So I think for the moment, I think we're going to put them into separate tables. That's what I'm currently thinking. Just in case we add some new thing to tagged files that shouldn't be queued, because the queued ones really are just paths. So there's really nothing fancy about it at all. Yeah, nothing fancy there at all. So I think that makes some sense. So we'll do it that way. So our flyway migration always begins with V, capital V, specifically capital V, and then the number of the migration. So this is going to be V0 underscore underscore. Excuse me. Create tagged file table.sql. Right. Hit the tagged file table. Yeah, that's really all there is. And then we write SQL. So we say create table tagged files, and we can either do that, we can do this. It's all up to us how we want to say this. So we'll just do create table tagged file. We'll do it like this, I guess. It's fine. Now here comes the thing that I'm not totally certain about, because like I said, I don't do SQLite very often, but I know from past experiences that it does have slightly different syntax. So let's say create table if not exists. That's fine by me. So create table if not exists, schema name dot table name, tagged file. I think we can just skip the schema name for the moment. Probably. Yeah, we'll skip that for now, I think. Or no, yeah, we will. All right, open up a paren, and then column definition repeat over and over again with commas. Maybe add a table constraint to the definition if you want, without row ID. And finally, as thing. Okay, so should be easy enough here. Anything special to look for here? Nope, not really. We will be setting a primary ID, so let's just use them as a reference. So this will be ID integer primary key. It doesn't really matter to me, ascending or not. Okay. Okay, so that's good. Let's go ahead and find the column def. Oh, column name type name. Yeah. Okay. No. All right. So let's look at our file class real quick for tagged files. So we're gonna have a path, which is a single string. So let's call it path. And this is it's got to be varchar, right? So we'll save 512 characters, I guess. I don't think I'm gonna need more than that. Pretty sure. I feel like that's way too much anyway. But it's not allowed to be null. So no null. And then, oh hey, I like this song. Is this really royalty free? It says no copyright. I'm trusting it. We have a maybe indexed. And that's a timestamp thing. So we'll think about that one for a moment. We said it's an instant here. And so I'm just going to save it. Oh, does SQLite have longs? SQLite Java time instant. Let's see what the internet recommends. Yeah, wouldn't that be nice? Because I'm probably just gonna do this long. Blah blah blah. Okay, whatever. No. All right, let's just search for SQLite long. Yeah, is there a type long? Nope. It's just integer. Good to know. Yep. Okay. So it's just a long. Fine by me. So it's an integer. And this is allowed to be null because it's a maybe. Yeah, let's just close some of these things out. Okay. And then finally, the tags are going to be pulled from a separate table. The origin as well. So path and index that and the ID. Those are the only things we really need for this. So this is our table. Primary keys shouldn't be null or can't be null by definition, but why not? We'll see. All right, so we call that good. And then we ask Flyway to migrate it to see how badly we messed up. So it's waiting. And it has failed because unable to commit transaction. Unable to restore auto commit to original value for connection. Interesting. It's probably because I don't even think I'm really running one. We'll see. The database file is locked. Really? What's it locked by? Let's just kill SBT in case I was holding on to it. It's interesting. The database file is locked. A good time. Hi. Try again. Reaction db.journal. And then it goes away. Huh. Interesting. So, yeah, that's unique. I'm vaguely assuming it's because it's not really running, you know, but I can't be sure about it. I'm used to just running MySQL. I just didn't feel like installing it, which I'm slowly starting to regret. 5 minutes left. Sounds good. Okay. Intriguing. Let's just open this container folder real quick and get bash here. And this is WinPT, SQLite, SQLite 3, reaction.db. Hi, how's it going? Good. Okay. Who knows? I don't. Help. Help. Stop. Stop. Womp womp. Well, let's go find out what's wrong with it. SQLite 3 locked. Yes. Please tell me more. You try to do 2 incompatible things with data at the same time. Like what?
Take your songs offline. Listen to it all ad-free. All your music, no interruptions. YouTube Red. Start your free trial.
Okay, framework. That's funny. Play framework. Hi. Can you tell me more about this? Because I don't really feel like I'm done much of anything, really. You know? This sounds closer to it, though. Because evolutions are basically the flyway of play. So, you know. Yep, 0. See, they create a table there. DB foo. Do I need the DB part? No, I don't. That's part of the folder path. So basically a non-answer. That's annoying. I don't want to install MySQL. It's really annoying. I figured SQLite would be the easiest thing to do here. Yada yada. Alright, well, you know, either way, I could still write code. It's just that I won't be able to really run it or test it, which is, you know, a bit of a problem. Yeah, I know. It's a rough life. I wonder if it's probably because the connection is pooling, isn't it? So when you have multiple connections and SQLite can't handle that. Has anyone used? If I set the number of threads and the pooling to 1, will it deal? Da-da. Ha-da-da. 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 So just gotta set the connection query. Okay. Hi. What? Oh, I'm on 2.6. That's why I'm looking at something that doesn't make sense to me. 2.3, please. Do-do-do. If that's the fault, then there really shouldn't be a problem. One. I feel like I should just set this to be 1. Since it's, you know, let's just ask it to be 1. Whoops, wrong button. Hi, how about now? How about now? Eh? Finger guns? Nope. Why are you so mean to me? I see that journal file, but I don't see it actually working. Those are thread pools, not the JDBC pool. Womp womp. Maybe I should just pivot and deal with it. SQLite does not support setting the schema, that's fine. It's just a bummer, you know? Because I don't really know what the database is locked by. All I'm doing is asking it to do one little thing. It's a bummer. Okay, well, I guess I'm not going to be using SQLite. So, such is life. That said, I guess questions 5 and 6. Let's do this real quick. Okay. So, that doesn't really help me. Yeah. Doesn't help me, I don't think. I'm saying reaction DB there, which is fine. And build, oops, sorry, not build. And flyway, I was saying to use the same thing, right? So that's not a problem. It's more or less just my own issue here. That sucks. Alright. Womp womp. Yeah, no, I don't know. Womp womp. Alright. Well, you know, such is life, and that's how it is. So, we won't be using SQLite then, I guess. Womp womp. Man, that's annoying. Okay. But the code will not actually be different. So this will work fine for a SQL database, so we'll keep that. We'll keep it like that and call it good. Next. And this is a personal preference, but I like trying to keep it to like kind of like one table per migration most of the time, unless they are like actually related. So this is going to be the queued file table. And the queued file is path and a possible index stat. That's it. Yeah. Actually, you know, the the tagged file, the maybe index that is really not, it has to be indexed. Yeah, so it's actually not null in this case. But it will be null, possibly in this case. Because we can add to the queue, and then kind of wait to index it, basically. And that'd be fine. Yeah, so all that stays the same, though. So there's queued file. And this is v1. Create queued file table.sql. Right? Easy peasy. And then for the next one, we'll have the file origin and the file tag tables. So just copy and paste, and let's do the file tag first. So our ID is going to be a UUID, and technically, I'm pretty sure we're gonna end up doing MySQL. That MySQL actually has a UUID type here. 8 apparently has UUID support there, but I'm pretty sure most of the time people just store it as a string. So yeah, it's just in a varchar 36, so that's fine. Oh wait, I think I've read this one before. This is the one where someone, yeah, he stores like the actual hex and just some crazy stuff in it, which is interesting, but not something that I feel like doing. Yeah. So varchar 36. So that's what we'll be doing here. So this is going to be file tag, and the ID is going to be a varchar 36, and that's going to be the primary key. And then, of course, the tag itself has a name. Whoops, that will not be a capital column. The name, and then a note. And the note is optional, which means that it will be nullable. And let's give ourselves some space here, 1024. Now the name itself for a tag really doesn't need to be 512 characters. Let's do 256. That's too much, but it's fine. So this is going to be version 2. Whoops. And of course the Windows swaps me up there. So migrations. All right. Create file tag table. And actually, we're not done with this table yet, because the other thing that we need to do is we need to be able to link this to the files, specifically to the tagged file, right? So maybe I should call it taggable anyway. So we need to make a foreign key constraint on this. And I vaguely, I always vaguely remember such things, but it's easier to just pull it from somewhere else and then modify as we go. So, yeah. So we're gonna create a table, and I'm pretty sure if not exists doesn't exist for MySQL. It might actually. It's been a while since I've thought about it. Alright, well anyway, let's just leave it alone. Alright, so we're gonna make a join table tag. So let's see, tagged files. Maybe I should call it taggable. Yeah, we're gonna do that. So, by the way, normally when you're working, how do you spell taggable? 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 Taggable. Okay, that's how you spell it. Taggable. Taggable file. So create file, file tag. Man, it is hard to come up with a name for this though. Sometimes I just, say blah to blah and call it a day. But create table, file, taggable, file to file tag. I mean, that's good enough for me. It's long, but it's fine. Okay, so taggable file ID, and this is an integer, or I think in MySQL it's just int, isn't it? I don't actually remember if I have anything. Yeah, it's just int. So we're gonna have to go and change things here. Hi. Int. I don't know, 10, 16, whatever. Sure. Like 9 would be fine. I really don't. Well, who cares? That's fine. It's all good. Ink. Okay. Can't be null. And a file tag ID is a varchar 36. Can't be null either. And then it is a foreign key. Gosh, this is gonna get even worse. Yeah. Because my convention would say this FK tagable file tag, or here we'll be. I mean, these names don't matter that much. Taggable file ID. Yeesh. Oh wait, that's the name of it. I named it. Yeah, we can just let it. You know what? That's what we'll do. We won't even give it a real name. We'll just let MySQL come up with it for us. So this is taggable file ID, references, taggable file ID. Wait, ID. Okay, and then foreign key, taggable file tag ID, references, file tag ID. There we go. And now we have a join table there. And just to check these things, let's go to what's the name of it? I used to know sqfiddle. That's what it is. Since I don't actually have MySQL running or anything, we're gonna ask this thing to basically do it for us. And just to make sure everything works. How'd I do? Alright. Duplicate key name, taggable file to file tag. Oh, I'm dumb. This is like A and B basic. This is the name. Yeah, okay. So we do need a name, or do we? What about this? Nope, we can do that. That's what we'll do. We'll let MySQL come up with the name for us. Okay. So there's that. And then we have one more table to make. Or one more migration to write, more precisely. and technically I could have done all this as like an initial migration, like here it is. I just prefer to do it one at a time like this because it makes it easy to find if you ever need to refer to a table definition, if you have like the table name in here and whatnot. So this is going to be a file origin, and a file origin has a UUID just like the tag. It has a name just like that, and it has a note. You might notice that this is very similar. Okay, so that's going to stay the same for the file, and that tells me that I have a bad comment here. Yeah, need to create the file tag table and the join table. All right. Key. So this is basically, we will change this to origin and call it good. And the music stopped. Has it really been an hour? No, but it's okay. That's cool. Go ahead to this one then, please. Anyway, okay. So the tag file ID will stay. The file tag ID will not, though. This will become file origin ID. Magical. Which is going to refer to this. And that's all. That's really the only change. So that should be good. And this is v3. Create file origin table.sql. There we go. I'll save that. Copy it. And we'll verify that I'm not totally crazy by asking it to be built on SQL Fiddle. There we go. So that's my way of checking my migrations, because I'm not going to install MySQL on stream. It's far too boring of an experience and tedious and error prone shooting. I might just install Docker and do it that way. All right, but anyway, so we can go on with code. So what we're going to do is we can break things apart however we feel like, basically. The way I normally do it is that you end up with a DAO package, and inside the DAO package you have things like, I don't know, taggable file DAO, and then that defines some methods, you know, like get everything or whatever. And then also inside the DAO file, you get, you know, packages for each database type you are using. And so you end up with MySQL taggable. I don't know why I keep thinking there's an E there. Taggable file DAO. Right, and so these guys are just interfaces, or in Scala they'll be traits. And then these are the implementation themselves, and that works fine. And then once you do that, you make the DAO classes so that they perform the basic operations, just the CRUD, you know, your create, read, update, and delete operations, and you know, also including like listing stuff. And then what you do sometimes is you make a service package, which, you know, we started doing here, right, with the configuration service. And the service package has, you know, things like the file service or something, and inside the file service, which will take in some DAOs as part of its constructor arguments and stuff, and they'll be injected. We'll have methods like, oh, I don't know, move file to from queue or something, like stuff like that, or apply tags to files matching X. And sometimes what ends up happening is that your services have they become pass-through objects, where it's like you have some method like this, right? List page per page. And this thing, the only thing it actually ends up doing is calling the DAO object like that. I'm just passing through. That's what I mean by passing through. Other things, you have your methods. Like this one isn't that great of an example. Though I get it can be an example. And inside of this one, you'd have some more business logic, you know, like so. Let's say it'd be like tags, you know, and it's a list of IDs, or for the tags that'd be strings, or UUIDs rather. So it's a list of UUIDs, and I don't know, basically some query parameter kind of thing. Apply tags to files matching blank. So, you know, in name, like we're matching the name, or the path rather, of the files. And so what we'd end up doing here, you know, is we might, you know, retrieve all tags by the UUIDs. Why? To make sure they exist, right? Or not. We don't even really need to do that. But, you know, something like this. And then we do, you know, find all files by in path stuff, and that could get us a list of IDs, and then we add things to join tool here. Could be a way to do it. That said, that thing could also very easily just be pushed into the database as a single, like, transactional operation kind of thing. So there's that. Basically, I don't really need to do this, like you could this is basically just like an insert select statement is what those could be. So yeah, so you know, you're always kind of, it's nice to bring things out into DAO and service stuff to have that layer, that separation layer, but sometimes you just end up with pass-through stuff, you know, like that happens. Let's go back to my example that I'm using. In here, right? So I have I have a DAO here for some expenses, right? And we have stuff like create new expense, list expenses during weeks, do this, do that. I can just go to this definition here, create list and add expense to a group, right? All this stuff, and it handles it, and that's fine. And in the service, we have a single service called the expense management service here, which takes in both DAOs and then coordinates stuff between it. But you can see that, you know, it doesn't really do that much logic. It does some recovery exception, handling things like that, but it's basically just passing through. Excuse me. But the reason to do that is because we have things like the configuration service, right, which actually does do interesting logic and things like that because it's a service thing. And then the controllers will be using the services, and the controllers will not be using the DAO directly. And so it's kind of nice to keep that those layers in place, even if it means making pass-through objects. But, you know, it's all good. So that's basically what we're going to do for a little bit, is make these types of things. So, anywho, first off, let's start with a DAO package, right? And in the DAO package, we're going to have a file DAO to manage the taggable file and the queued file. We could have a DAO for each, and there's nothing wrong with that. I'm just wondering if we should or not, because one of our main operations is going to be moving a queued file from the basically the to-do queue, and then adding it into the taggable ones. And it'll be easier to do that without pulling things up into memory. So having two DAOs would mean that we would do like get all the queued files that I'm talking about or something and insert them into the table file. Meh, I don't know. Let me think here. Now that I'm thinking about it, I'm almost feeling like I should just combine the tables together and put a flag, just a Boolean flag into it. Namely, because basically the view that we're going to have here, the view we're going to have will let you swap between, the queued and like the to-do kind of things that haven't been tagged at all yet versus the ones that you have tagged. Yeah. So there's that. And that really just be an update to the single table to make it say is true on whether or not it had a tag or whether it's been seen really. Kind of distracted by the song a little bit too, to be honest. It's kind of fun. Anyway. Let's just keep it like this for now, I guess. Yeah, let's just keep it like this for now. It's fine. And let's make the queued file one first, just because. Okay, so we're in the DAO package, and we're making a trait, and it's going to be called queued. I always look at queued and wonder if that's spelled right. And we're going to make a queued file DAO, which basically is just a thing that has methods. And so we want to be able to queue a file or something, add the queue. Yeah. So we'll be like, hey, add new, and it'll be a let's see, we'll take in a queue file. Basically, we are gonna take in one of these guys. So I'll need to import model.domain. .scala. And this is going to end up returning something. We haven't decided yet, though, what it's going to be. I mean, we could return a Boolean for yes, it is entered, or no, it's not. Whatever. There wouldn't really be a problem doing that, I don't think. But who knows? We could just return the thing that will be indexed, essentially. And there'd be nothing wrong with that. We could return whatever it is. But I think for now, we'll just return a Boolean and call it good. With the queue file, we'll need to also have a delete. Right? And we'll be deleting by ID, which is an integer. Right? Integer. So you send along, it will get delete. And delete can return a Boolean as well for whether or not it did it or not. And then we probably won't really be updating the queue files. Like, there isn't a particular reason I can think of. When we're going to traverse the directory tree, we're going to grab paths out, and then we're going to call add, which is It's fine. One thing we will need to do though is we'll need to check to see if it already exists in the queue. So we'll check it by an ID. And the reason we'll be able to check it by ID, here we'll make exist by ID, is because the IDs are the hash codes of these objects, right? Which theoretically, I believe, should mean that since these are case classes, as long as these fields are the same, then we should end up with the same hash code, I believe. So let's just verify that. Okay, so we'll import Java path. Okay, so we'll make a queued file, and it will have new path right here, please, and no index that yet. Oh, right. I always forget that. How's it? Paths.get. And we have to actually import paths. There we go. And then we'll make another one. Now, res2.id, I believe, should be the same thing as res3id, right? Because they're the same hash code, because they're the same same path, same everything, really. So I should be able to, when I'm doing the directory traversal and constructing queued files with these paths and a none here because I haven't been indexed yet, I should just be able to send the ID and then say, hey, do you exist yet? And then I'll get it back. That said, once I've added, if I say something was indexed at a certain time, that will change the hash code, you know? So in that case, a queued file with any kind of update, which I already said we're not doing, so it's not really a point to talk about here. We'll be a bit different here. The one thing where I'm wondering about that is how that's going to affect the tagged file ID, since the hash code for that will change as different tags are added, which means that I don't like that. I do not like that at all. Yeah. The ID being the hash code is useful for the queued file, less useful for the tagged file, it feels. Because since the ID will change based on what's in these fields, then if I want to do an update, or not even an update, but have a form on the page that addresses a specific tagged file, the ID will always change as I add tags to it and whatnot, which is kind of a pain. So there's that. So ID really needs to be a field. Oops. You know, ID really needs to be its own field here for the tagged file. It doesn't need to be for the queued file, because the index that when we traverse the directory, we're not actually gonna pull anything out there. So there's that. ID might need to be the same for both, to be honest. It might need to be a field on queued file as well. Primarily because because if I have code like this, like add new, right? Unless I'm very careful about this and do something like queued file dot ID, and then queued file maybe indexed at some instant dot now. That's what I'm gonna insert. If I insert that under or as that ID, then it'll work fine when I go to check exists by the ID that doesn't actually have an instant. But it feels a little brittle, doesn't it? It feels a little brittle. Which makes me want to say that, hey, maybe it should have that. But still not great. Not great here. Because I could use like a tuple or something, you know. It's like something like this. I don't know, .1. And then take this thing's hash code compared to this thing's hash code. And they are going to be the same because it's a tuple. Pretty sure if I call hash code on paths.get, it won't be. Kind of like if I wanted to construct a queued file from just the path in a relatively quick manner. You know, basically if I had a companion object for a queued file that had an apply method like this, and it gives you a queued file with, I'm pretty sure, when it comes to Java objects, I don't really expect them to actually implement their hash code function correctly. But maybe NIO is different. Maybe. I don't know if I believe it to be. But anyway, I could do something like that, though, you know. Path, none. Right? Like, and that could work fine, because then I'll always have the correct ID, basically just the ID of the path itself. You know? But I really don't trust hash code against path there. No, I want the actual path. You know? I guess I trust it. It's based on the components of the path and satisfies the general contract of the object hash code. Yeah. I guess for now I'll trust it. For now I'll trust it, I guess. But yeah. So same here with a tagged file companion. Well, I suppose I don't need to be that kind to this one, I guess. Because these I should be making from the database, typically. These ones I have to make in code during the directory traversal. So, yeah. So we'll call that okay for now. Anyway, back to this stuff. We're not actually going to have any real code here, because this is just the trait. Technically, you can put code into traits, but for this case, I don't want to. So, checking exists by a certain ID, and we have delete, and we have add new. So that's pretty good. Yep. So that seems pretty good to me. And again, this is making me think that I actually do want to store my files into the same table, because that way I can check the existence check should be against both the queued and the taggable ones. Excuse me. In which case we would make add queued or add file to queue, which is fine. We could actually even just take an abstract file there, to be honest. And we could just call it a day, because technically we'll take in the queued file. It makes sense. You wouldn't add something else to that. Okay, so delete and exists. And what other things do we need to support for this? So we're going to traverse the directory tree. We're going to check to see if certain paths exist or not. And this is actually just going to be found now. Made a decision on that. Fine. I'll hit enter for you. Exists by ID. Add file to queue. We're also going to need add what do I want to call this? This is our add to file, or sorry, add file, add taggable file. Let's think about this. So like we have this queue of files, right? Q. And then we're going to have the other files, the taggable ones. And as the user looks at a file, so here's a set of eyeballs. They're looking at a file queue, and they say, okay, that's good. Let's add this tag to it, and now you have a file. And since you did that, the file is now updated to is tagged, essentially, right? So we're transitioning from a queued file into a tagged file, and that swap in our database, if we could either be moving a record from the queued file table to the taggable file table, or if we have in one file, then we'd have a Boolean field on here that we set to true or false, essentially. Yeah. But I do like the idea of keeping them separate tables at least. So I don't see an issue with that. But so we will need an operation basically to move a file. So move file off queue. Well, I mean, removing is just deleting it, really. But since this is the file DAO, we need a thing for add file to, would it just be add file? Add tagged file. And we'll return Boolean for that as well. We could make these return futures if we wanted to. And we might do that, but I'm not totally caring that much about futures and things like that currently, since this is a thing that I'm not super caring about. The only thing that's going to make me return a future here is if the anorm stuff forces me to, essentially. Which I don't know if it will or not. It's been a while since I looked. I think I normally have to wrap it in the future to make it be pretend async. So, hey, come on. Okay. So, well, you can get a stream back. Or you can execute some queries, get some results, you know? Yeah, as that. This, yeah, it's not going to return a future to me. So I'm okay with not dealing with that right now. I mean, when you use a future, you're really just gaining, you're putting more pressure on your CPU than you are your I/O. So it's a balance. Anyway, okay. So we'll have that method for adding a tagged file. And so we should have this. We'll call this actually remove from queue. And I don't really care. I don't want to do that actually. I don't need to write methods for methods we don't have or we won't use. Basically, once I add a file in, I don't know when I'm going to need to actually delete it. Like, removing from the queue makes sense because we're going to be essentially pushing things off from one end to the other. Removing files that have already been tagged. I mean, it is technically something we need to do, I guess. Like, if we delete a file from the database, then, you know, we'll have to do that. So, it'll be that. Now, exists by ID here. We'll have that check both queued and tagged files. I think is what we'll do. So we'll just make a note of that. Queued or tagged. And let me think here. Yeah, that's that for that. We're never going to update paths here, especially since the ID is based on the path. The index set property, we're going to set it when we create something. So basically, you know, when we add a file to the queue, this is none. We haven't indexed it yet, right? Or actually, sorry, it will have a thing. Yeah. So, yeah, there won't be an update, basically, is what I'm getting at. So, no need to actually implement the method because we won't need it. Yeah, and that's that. So, these are our 5 operations that I think we're going to need here to support what we want to do. Exists by ID supports for the directory traversal, removing a queue. Removing something from the queue is really for if the file suddenly gets deleted, or the file gets deleted, or we have tagged the file, like we have looked at the file and been like, ah, yes, we'll apply this tag to it, and then it gets taken off from the queue, and we add a new tagged file in. And removing a tagged file will only happen if a file goes missing, basically. When we move a file, though, that's a good thought. When we move a file, like on the directories inside the operating system itself, we do actually need to update its path, right? So in that case, we do need to have something in there. And so that actually applies for both cases, for a queued file and for a tagged file, because even though we've set up a file to be queued, well, actually for the queued one, we could just manage that with remove from the queue and add it back to the queue as a different thing, and that'd be better. For a file that's been tagged already, though, actually, yeah. When a file exists, when a file is moved for a tagged file, we actually will want to update the path. We don't want to lose the ID by removing and adding or anything like that, and we don't want to lose any tags that are already applied to it. Which means, of course, that we do need a method for that. So we'll have update path. Oops. For something to something else. There we go. And that'll be good, I think. And we'll say yes or no, it did get updated. Yeah, and I think that covers most of our cases here, I'm pretty sure. So we're going to have to deal with, because the file monitor will send us updates for delete and adding, and I think for moves. I think. I had to check and look at the kind of like file events and whatnot, but that's not today's plan. So I did update this exists by ID method to return a file exists trait instead, which I'm actually going to store in a package object. Just for code organization, because I might use it again, you never know. File NIO path. What? Oh, I have that backwards. Ow, all of a sudden, ouch. Like right above my right eye suddenly started aching. Ow, what's going on? Ouch. Sorry. Right. Okay. Anywho, I suppose we'll actually just take away the implementation detail from the trait and then leave it as is. Okay. Yep. Okay. We're going to return a file exists from exists by ID. That could be it doesn't exist, or it exists in the queue table, or it exists in the tag table. That way we can decide what to do based on that. Because when we are traversing the tree, if we get an update about something being deleted, or sorry, if we check for the existence of a file, it's already in the queue, then we don't need to do anything. And if we check for it and it's already in the tagged things, we also don't need to do anything. But we might also be wondering why the heck are we getting an update for something. I don't know. It just seems cleaner that way, since we're going to be returning data from two possible tables to provide the information to us if we ever need it about which table it came from. So, you know, just because. Okay. And so this is our DAO object that defines the traits for what defines the methods that we're going to be doing for all this stuff. And we're just going to have a return we're going to have a return blocking booleans and a file exists and call it good. It's going to be a good day. So the next thing that we need to do, of course, is we're going to make a MySQL package. Originally, we thought we were going to make a SQLite package, but we're wrong. Which is kind of a bummer, really. I was looking forward to trying something new. Anyway, so let's go ahead, and this is going to be the MySQL DAO. Now, the important things here is now it's an implementation class, which means it's, an implementation. We're going to have a constructor that's annotated with JavaX inject so that Juice can provide us with everything we ever wanted in the world. And then the other thing, of course, is that we're going to need some database access going on. So we're just gonna do this real quick, just because. And in order to have a database object, we're gonna take in the DB guy. See, so you need a connection to run a query. You can retrieve one from the Play API DB helper, which is this thing db.with connection, which requires an application to be in scope. So we're gonna take a look at this. See, it needs an implicit application. I don't think we want this one. Nope. And nope. Yeah. So we're gonna deal with this. So we don't actually need to inject anything from the looks of it. We just need to have a running application. Womp womp. Which is fine, I guess. So the actual constructor argument that we're going to take in is the application. And we'll assign it into this. I actually don't know if, I think the Juice can probably inject that. Anyway, we'll do that. And then we'll have play.api.db. db. And we'll be using that. So we'll be doing this, the loan pattern business here. So the connections are automatically released and etc. So when we add a file to a queue, we're going to call db.withTransaction because it's a transactional operation, right? And then we have an implicit connection going on. And then we'll do something. In this case, we're adding a file to a queue. So we'll hop back to get the insert going on. It's not that crazy, but we need to use execute insert here. So, but then again, I guess we won't be doing that. When a key generated on insertion is not a single long execution, insert can pass the results apply, search on the right key, yada yada, yada yada, yada yada. We're just going to use execute. It returns a Boolean value about whether it was successful or not. And that is good enough for me. We also need to import a norm. Okay. So you can see we are going to do SQL and execute. So we'll say insert into, and this is for the queued file, which means we're going to be storing it into here. Insert into queued file, ID, path, and maybe don't really need that one, or this, or maybe index that, because I'm pretty sure that's what we called that one too, right? Yep, maybe index that. Values, and then we're gonna take in ID, path, and maybe index that. Easy peasy. And since this is gonna have things bound to it, we'll be calling on, And then also super easy, we pass in things like this. So on queued file .id, and the path, of course, is going to be set to queued file .path to string. And we're actually going to have to do to absolute path to string. And then maybe index value at will be queued file dot maybe index that, and we know that that is an instant, and we want to store the instant into an int, which means we need to store it as as epoch second. Seems like a good one to do. And let's just make sure that I'm not crazy and that is the actual method I need. Yep, get epoch second. See? There we go. And let's compile to see if it is to absolute path or not. Okay. So, two things. One, we need to import DAO._, because I also forgot to do this, and because we need to have that package object in scope in order to get those return types. Then the other thing, of course, is that I forgot to include app. So we need play.api.application to be there, otherwise you don't know what it is, and then it will work, right? So this should technically work. And that's fine. No problem at all. We'll just organize things a little bit. Even though Scala reform will probably do stuff anyway, but you know, whatever. Oh, I totally forgot. We forgot something really important that I'm kind of dumb about. We need to be able to get them. We need to do the listing. So we'll need to take in a page and a per page. Yeah, so that we can construct views of these things. And since this is for the files, we could have it choose how to do it if we want to deal with stuff. So for example, I could have it like list everything, or list some of them, or whatever you want, really. And we could do that as separate methods, or as like an argument here to tell us which table we're supposed to talk to, as like kind of a sealed trait thing or something like that. But I think what I'm going to do is we're going to have list queued, and this is going to return a sequence of queued file, and we're going to have list tagged, which is going to give us a sequence of tagged files. And it could be a sequence, it could be a stream, because anorm will return a stream to us. I think it might also return a list. Let's double check. Let us double check here. Whoops. So anorm here with your SQL query result, right? And apply will give us back a stream. And then there's a list method, and that gives us back a seq. So that's probably what we're going to end up be using most of the time. It's just this list and giving a row parser to parse each individual thing, and that'll be fine. Yeah, so we'll just return a seq. So now we'll be able to list queued and we'll list tagged. And to make it clear, we'll have pagination be 0 based by setting this to this, like that. And per page, oh, I don't know. How about I don't know, 12 or 24. How about 24? 24 is a decent number. Maybe 32. Who knows? Either way. we'll just set some defaults and call it a good day. So we'll have that go on there, and then in our we'll add a couple fake implementations here just to have them there for the moment. By the way, if you're not familiar with the triple question marks, it means throw a not defined exception. Okay, so that would do that. And if I actually had a database running, then we could set up some tests and do it. But for now, we can't, so we'll do it next time. Instead, we're gonna write the SQL. So adding a tagged file, this is going to return a Boolean again, and this is going to be fairly similar here. The only things, of course, is that we're going to be doing kind of two operations here, or three even, because the tagged file can have, it has the other stuff. Excuse me. That's the other ones though. Yeah. The tagged file has the same fields as the queued file, but it also has tags and maybe origin, which is really, for populating on the display on the back. But technically, we could make this thing when it adds a new tagged file in, add in a tag. My thought originally is that we're going to have a DAO for the file origin and also the file tag, and the associations between these things are going to happen in those, not in the file DAO. So we can make a note of that here. Oops. Does not link tags origins to file. And this, we'll put this in as a note. Please call appropriate methods in relevant DAOs to do so. I'll do that just so it has that. Add a file to the database. Alrighty. So we'll just have that be, insert into, and our database token is taggable, right? Taggable file. This is going to be, basically this is the same thing as this. So we'll just copy it for now. Like that and that. We'll call it a good day. Yep. And then literally the same here, just changing these things. So, and save that, compile it to give Scalariform a chance to have fun and wonder about what's wrong with everything here. And it's because we forgot to do this. We forgot to give it a transaction, or specifically a connection, which we get by calling the DB with transaction there. And we get that. So that works fine. Yep. And no problem at all there. Though the formatting is kind of funny and off. Is that okay by you, Scalariform? Okay, it's okay. So easy enough to do. Removing from a queue, easy, right? So again, DB with transaction, right? It's an implicit connection. If you just say connection there, it will not work. And then we'll use triple quotes just to make it easy peasy to read for us. Now we're gonna have on ID that. So this will be a delete from queue, delete from queued file, where ID equals ID. Oops, I'm still not used to the really typing on this keyboard. And let's just make that capital there. So that's that. Easy peasy. And of course, execute. And done. remove tagged file. This is the exact same code, except instead of queued file, it's taggable file. Easy again. So easy. We could probably just turn this into remove file and make it take in a single argument or something like that. It wouldn't really be a problem. But for now, just keeping everything simple and contained, we'll do it like that and call it good. Whoops, I don't want the console. I just wanted to compile. Exists by ID. This one's fun, right? Because now we actually have this going on. So we actually get to do a select now. Everything else was just stateful things being like, hey, do this, right? Which we could continue doing real quick. Let's actually just move this method here. We'll just get all those done first because they're really simple. And so in the update path, cb dot with transaction. Oh, know what we didn't do here? We didn't say what we're updating. If it's a queued or a tile one. We're gonna say that, like that. Because we're not planning on updating a queued file. Yeah, because the update will just be remove it and add it back in. It's not, the most efficient thing, but it'll be fine, I think. If we feel like changing it later on, we will. So implicit connection for our update. We're going to do some SQL, which will be update tago file set path equals path where id od id equals id. All right, and then we'll bind both. So the path will be the path to absolute path to string, and the ID will be the ID, and then we'll execute. Ta-da! And there is a specific, there is execute update in here. It returns number of rows. Meh. I'm fine with just execute right now. Because really, if it doesn't exist and I have tried to update it, it doesn't change the state of my database, so I don't really care. All right, so now back to the more interesting one. Exists by ID. So exists by ID is a read-only operation, really. So we only really need to do connection. Normally what I end up doing, and I'll show you it real quick. I normally end up making my own connector here. This is when I don't use plays DB. And the reason for this is because I like using read-only connections. So read-only connections are nice because it lets the database know that you're not going to do anything, which means it can apply certain optimizations, which is really, really nice. So we're going to actually steal this function and do it, basically. But I want to be able to do it for everyone, essentially. So we're going to make a package object here. Package DAO. Package MySQL. And we're going to have a thing with read-only connection. And it's going to return some type. Let's call it R. I think the reason I called it A before was because it matches up kind of to the ANORM stuff, but let's just call it R for result. So it's going to be a connection to an R, whatever that may be. And it will return an R eventually. And what we do with this is connection bar, blah, 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 do this stuff. And so let's think here. We're gonna take an implicit application. So actually we'll call it app. Oop, I hit backspace. Let's just make this slightly more readable. Only slightly though. And we'll end up calling db.with connection, not transaction, important. We don't need that. And we're gonna get a connection, right? And then we're gonna do some try catch. We don't need to do a catch actually. We'll do a try finally. And basically what we'll do is before we pass the connection over to whatever the calling code is, we're going to set it to true. The other thing is that we have to set it to the auto commit to false, otherwise it doesn't actually work. I know it sounds weird, but that's how it is. I don't remember if auto commit is the normal thing or not. I think it is. I think it's true. Yeah, automatically committed. So, pretty sure. And so we just call the block with the connection, and that's that basically. And the auto commit thing is there because if I remember correctly from when I wrote that code half a year ago or so, that the performance gains you get by setting something to be read-only doesn't actually happen unless you set auto commit to false, and that might be a MySQL specific quirk, but either way. So yeah, there's that. We're gonna need to import play.api.application, of course, as well as play.api.db, and also java.sql.connection, I think is the package. So let's find out if I got any of that right, shall we? Oops, I said console again. Expected class or definition. Oh, I forgot the word object. There we go. Alright, how close we got? Pretty close. Nothing wrong with this file, at least. What? No, I don't want you to do anything. Okay. So, this one we're going to say with read-only connection like this. Yep. So we can use this basically like the other one. Like this, right? And then exists by ID is going to be yank. So select count star from queued file where ID equals ID. Easy enough, right? And we're gonna. This is essentially what they give you an example of. See, select one, execute result boolean. Yay! That's exciting. It's not really what we want though. We're gonna need to call as is what we're gonna have to do here. So you can see that the SQL parser from anorm has some handy dandy things we can use to really easily just get back stuff. So we'll use that. So here we go. We'll pull up a SQL parser object here, and you can see we can get a bool, we can get a byte, we can do all this stuff. We're going to be using the int specifically, and for some reason I feel like there's a instead of an as thing, we'll just use single. I won't call it a day. So that's going to be single and SQL parser dot int. So we'll say this as C, and the column name is C. Don't know if you saw that before or not, but we say like long that or int column name, and we get it back. We get back a row parser for that, which matches up to what we need here. See? Perfect. All things good. Okay, and so that is going to be found in queued. Simple enough. And then we're also going to have a found in tagged. Now, I would expect it to not exist in both. You know? Just wouldn't expect that to occur. Because it shouldn't. I suppose theoretically it could. But it's not something I want to have that happen. So, found in tagged, found in queued, and we'll do a match statement against this. Yep, and these are primary keys, so there'll only ever be one. Man. I suppose I should have something in there, huh? Exists in both. Yikes. Hopefully we don't ever actually get that. But, well, we might. Alright, so I'll just put those there as reference, right? So, in the case that there are none in tagged, and there are none in queued, then it doesn't exist. However, in the case that there's one in tagged and none in there, it exists in tagged. You might see where this is going. Exists in queued. In all other cases, it exists in both, which is weird, right? But we'll just hope that never happens, right? Oops, I forgot this. We forgot this bit. We had to parse the result and call it a good day, and then check out what it's yelling about. Since method update path is not defined. Oh, right. In this, we changed the name, so I'll change the name there, and then I'll call it good. So we get some deprecation warnings. Method single and trace was defined. Use as with row parser dot single. Fine. So row parser dot single, huh? Now, is row parser an actual thing? Appears to be. But I don't really believe you. So, I assume what it means by this is I had to say as. And give it a thing. And then do something dumb. Why'd I want to do that? Method single and trace equal is deprecated. Use as with row parser instead. Okay, I get what you're saying. I just don't really like it. Fine. Okay. So, sql int dot single. That's what it's telling me to do. Seems like a random, kind of an arbitrary choice and deprecated thing, but whatever. Sure. So as an integer of single. So easy enough. And there, that's our exciting method. Listing queued and listing tagged is more fun because we get to do some math now. Specifically, you're joining your offset math. So the page is 0. That's fine. Basically, we have to set limit, which is always going to be page, and then offset, which is going to be the page times the number per page. Yeah, pretty sure. I can't remember if I need to do a -1 to handle things. Basically, when we get 0 and 2, say you were only asking for 2 per page for some reason, then you're going to get back 2 records because you limited to 2 things and the offset is 0. On the next time, you want what? An offset of 3? Still a limit of 2? No. No, I think that's right. Yeah, since it's 0 base, I think that's right. Because page times per page gives you how many to skip up. So, you know, you get 2 and 2. Yeah. Yeah, that would work. Okay, so I'm pretty sure it works fine. So we'll call that good. And then with a read-only connection, and you know, once I actually next stream, when I install MySQL ahead of time and everything, we'll actually check and make sure everything works. So we want to do some MySQL, and we're going to select. We're going to select the ID. This is listed queued. We're going to list the ID, the path, and then maybe index that from queue file. And so this is the part where I start actually using the fact that I can go across multiple lines to make the SQL a little bit easier to read. From queued file, where, actually sorry, not where, there's no need to where, but we do want to order by ID, because you want an ordering when you do pagination, otherwise it's, you know, at the mercy of everything. And we're gonna limit by page, oops, limit by limit, comma, offset. I think that's how it is, right? It's limit then offset. And that's that. So we'll bind our parameters, of course. And the offset. And you'll note that I just wrote the exact wrong thing because I was just thinking faster than I was typing there. Limit. There we go. All that stuff. And then we're going to do as. Now for this one, we could make a row parser for the type, and that would be fine. We can also follow their example here, right? And we can do things like this, where we said, oh, this and the little squiggle, little tilde, to combine things together and then pull it out. And that works just as well. There was an example I saw before that looked interesting and kind of like one that I wanted to maybe do, but maybe not. Let me just look through real quick. Yeah. Yeah, if I don't care, we do order and type and match the row here. Could do that. Could also not do that. Yeah. Nah. We'll just we will just deal with it with the parser API. Yeah. So it's pretty easy to find your own, and it makes for reading nicely. So basically, what we had to do, and we'll do this in the package object after. I'll do it in here first, just to do it. So we'll have our queued file parser, and this is going to be a row parser, right? So the row parser just takes a row and returns a SQL result. Nothing too crazy. Because we're going to be passing it to here, to this row parser. I think you can actually make row parsers out of reset parsers. That'll also works fine. Yep. Yep. Yep, yep, yep. Pretty sure. So we're gonna make a result set parser. Ooh. All right. More no copyrights, please. We can just play the one before this. That'll be fine. This is fine. Okay. So sorry, result set parser of type queued file. And I'm just going to verify with myself that this is what I want to do. So sometimes I make these parsers. Oh, I made a row parser before instead of result set parser. I mean, it doesn't really matter that much to me, to be honest. It doesn't really seem like it'll matter that much here. Basically, the difference between a result set parser so a row parser I can star, I guess. So actually, I suppose I do want that. Yeah. When I call list, I want a row parser. Yeah, okay. So we'll make a row parser. So all we have to do is define an apply method that takes in a row and returns a SQL result. Easy enough, right? So apply. I don't know why it's a v1 here, but we're just going to call it row. Okay. And then with each row, excuse me, Mr. Row, we're going to ask for the type out for it. So we can say, we can basically do things like this. Like this is an integer, right? For ID, please. And then we squiggle our way to victory, I'm pretty sure. Pretty sure anyway. Yeah, there we go. Combining these things all together. So well, that returns a result. Let's look at her. Oh, it's get that I always end up calling. Why do I not see get in here? What? I'm confused. I feel like get is part of something else. Yep, this guy. Here it is. So that's from SQL parser. Right. Okay, everything's coming back to me now. Okay. So this is going to be a row parser of queued file. It's been a little while since I did this. And we're going to make one. And so I'm going to import SQL parser. And then we can call get an integer called ID. And then combine it, yank, with a string called path. And then combine it with another thing, which is a, I think there's a get for that, but I feel like there's also an option version. No. Okay, so you just option it. So get an optional int for maybe index that. Right, and then, excuse me, I don't want to be in insert mode. Once we have that, we have a row parser that we built up with all these things. I mean, technically we actually have this some madness going on. We have a row parser of all sorts of other things. But anyway, we can then map it. So we actually map this. BIT, this is a string path, and this is a maybe int. And then we turn our thing into the actual queued file that we want. So the ID doesn't need to change at all because it's the ID. The string path does though, because it needs to be paths.get the string path, and we'll have to import that. And then the maybe int, we're going to apply instant dot, is it from? I can never remember. Is it from epoch seconds? No. Of epoch second. Oh, and it actually needs to be a long too. Look at that. So this needs to be pulled out as a long. And that's fine. And we need to import paths. Oh, nope. We're so close. There we go. And yeah, so now we have that, and that should work. And so we do this as, and actually we don't do it as, we do list. Because it's going to be our SQL query result. And we're going to call list with the row parser, and it's going to give us back a sequence of A's, which will be, in this case, a queued file. Provided that we did that right. Now the other thing that I like to do is to be explicit with these. And the reason for that is when you start using these row parsers that you define here again and again, specifically when you join tables, it makes it a lot easier in life if you refer to them by their full name. It might seem a little odd to do it now, but trust me, it's a good idea. All right, let's compile and deal with all the errors. Okay, so we have found T1, T2, T3 required. Main. Oh, right. I always forget that. It's not that I'm matching a case thing here. I have to match it with that like extracty bit kind of thing. And then I need to import instant. Import java.time.instant, not inject. Instant, yay, and let's put it above Neo. There we go. And then of course we have this. I have to listen, trade, use as with row parser.star. But why? Why does it want me to do that? Why? I don't want to. The star returns a list. I want to return a seek. Because you see, it makes me less happy to do it like that. Because doing that now means, well, I guess it's fine, but it's still annoying. Okay. Anyway. So, there's that. Is it Scala reform pushing these over? Or it's just me? No, it's Scala reform. Okay. So there's that. And that should work. And now you can see that I can just move this into here so that all my DAOs can use it, which is what I want. And we're going to import model.domain here as well, and import java.time.instance and java.nio.file.paths. Yep. So, how does that compile? Besides possibly being angry at me. Okay, we're good. So, save that. And we're good. The other thing we can do, of course, is this row parser, it doesn't really need to be used outside of our package at all. So, we'll make this package private. And I think that should still work. Oops. Okay. Sorry. Yep. Because there isn't really a reason for it to be allowed to be used outside of it, outside of this package. So we'll do that just so the compiler doesn't have to think about anything ever again. Okay. So that's good. And then we basically are going to do the exact same thing, but for this. and we'll make ourselves a tagged file parser. And we will, of course, also update this. So, yoink, 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 yoink. Call it a day. Of course, the other thing, though, is that we'll need to do more than that. We need to do more than that with this. Specifically, we need to do joins. So, yoink. And those joins, so we can do this a couple of different ways here. We can do some exciting cross-join business. So we'll join on the IDs with the tags and with the file origin. The only problem with that, of course, is that we're going to be returning a lot of rows, which is less than great. So like, joins are great. They're good for doing stuff. Joining two tables together with another table is less great. There should, let me think about this real quick. There should only be, I guess there could be multiple origins associated with a single file, right? No, we've defined it so that it's only an option. So that should actually go into the table instead of using a join table like we set up in the other SQL stuff. So we should fix that. And then that makes me less inclined to break out that join. Yeah. So we can do it one of two ways. We can do the join, and then we can collect all the tables and group them by stuff, and etc., which will work. We can also do two SQL statements. You know, one to get all the tagged files, and then another one to collect all the tags for said files, put them in. And it's kind of up to us which ones we want to do for that. You know, your database is going to end up sending extra rows or extra data. Sorry, in the case of the join. Which isn't a bad thing. It's not really a problem since this is all be running locally. Like, network is not going to be a problem. So we might as well just keep everything simple and call it a day. That said, I do need to correct this thing, the origin. So let's do that. Actually, we'll keep it like that for the moment. And then when we create the file origin, let's say update tagged file, update tagged file, yada yada. Actually, you know what? This is going into here. Say goodbye to migration 3, boys. All right, and girls. We're going to create the file origin table first, and then we will have file origin ID. Yep. And that will be a varchar 36, and it is nullable. And we'll just do it like this. References file origin ID, like that. Okay, so let's just verify our SQL real quick. So we'll drop this part out, and we'll put this above there, and we'll remove this one, and we'll ask it to build the schema. There you go. Looks good. Okay, so save that. Save. Close. Close and no. Okay, so now we got that. Yep. So we can leave it like that if we want, but we'll just keep it in here. We call it file origin ID. So, and what maybe origin is what I called it there. There. Tagged file. Oops, come on. Tagged file. Maybe origin. Pull out the ID. And we need, of course, that. And that ID of the origin is the UUID, but we don't want the UUID. We want a string version of it. So toString. There we go. And right, can't actually compile yet because I haven't finished. And so we're gonna pull out type of file. Here we go. Left join on file origin. Right, that's the name of our table, file origin, which has an ID, name, and note. On table file origin dot file origin ID equals file origin dot ID. Yep, and then we'll file origin dot ID and file origin dot name and file origin dot note, and that should be good. Okay, so next let's define this guy. So it's gonna be pretty dang close here. It's a row parser of a tagged file type, and the reason I import this is because I don't want to write SQL parser.cat, SQL parser.cat, SQL parser.cat over and over again. So we're gonna grab all this business here, and of course it's all this. So for reference, we'll just paste it there real quick, and we can grab the top three. Whoa. Mine. Yeah. Yep. So like that, right? But then the tagged file one also has these other properties. So we'll go ahead and we'll pull these in. So file origin ID is an option. All these things are options because we did a left join. But this is a string, which happens to be a UUID, which we'll have it turn into that once we're out. So here we go, right? And then the name as well, and the note as well. So you can see file origin.note. All right. So we'll combine all these together, okay? And then we map. Right, so we map case. We have our main ID here. So this is the file ID, if I could type correctly. The file ID, we have a path, we have a maybe index.int, we have a maybe origin ID, we have a maybe origin name, and we have a maybe origin note. And once we have this stuff, we can work on it. So the first thing that we probably want to do is we want to make the origin. So this will be our maybe origin. Okay, so this is going to be a file origin eventually from this yield with an ID, a name, and and a note. So the ID here is going to be maybe origin ID. And the name here is going to be the maybe origin name. And then we won't comprehend over the note. You might ask yourself, but why? Why not? So when we do a for comprehension over an option or a set of options like this, if this is empty or this is empty, this will be empty. Because the origin note is an empty field or an optional field for the file origin, it's okay for it to be empty. And we don't, if it is empty, we don't want to have the entire thing come through as not being there. So therefore, we only comprehend over these two. Easy, right? Okay. Next thing, of course, is basically this, right? Except it's a tagged file, right? We're going to give it the file ID. We're going to give it this path, and watch it just rename to be string path. And then the maybe int will do the same thing. Then we have no tags currently, and we'll get to that. Okay, we will get to that. But so we're just going to have an empty vector. So vector empty of things, of file tag for the moment. And then, of course, the possible origin of the file goes in there. So let's just for consistency call it maybe file origin, right? And then I think that should be good, and we'll do some checks. So line 44, we have an issue because I didn't delete my my extra stuff here. Of course, I also didn't close my my things here correctly, so both of those get closed. And then we're happy there, and then of course the UUID also. So to construct a UUID, there is a method for it. And I think it's like UUID. I think this is a from class. See, you don't use this unless you like know what you're doing, but we instead use the from string, right? So we're gonna have UUID.fromString. And actually, Anor might actually have a UUID parser built in. I don't remember. Let's take a look. Row parser, object, or sorry, SQL parser. If I could spell it right, that would work a lot better, wouldn't it? SQL parser. Maybe not. Weird. At some point, I thought that they had one, because I know I used it at one point. Fascinating. Okay. Just stating, I'm pretty sure I saw it at one point. Guess not. Alright, anyway. So there's that works. You just have to actually import it. And UUID is of course from util. So we'll go ahead and we'll compile that. And ta-da, successful. Because now that that exists, we're able to do this. Okay, so this gives us our tagged files with that tags, which is pretty close to what we want. Not quite what we want. So now we need the file tags themselves, right? So we'll collect all the file IDs by taking all the tagged files without tags, and we'll pull their IDs out. See, so here's all IDs. And then we'll do a SQL statement. Right. Now, of course, if that's empty, then we don't need to do anything at all. And I believe, and SQL will actually give us an error if we don't guard it. So we will guard it. So we'll put a thing here. If tagged files, that IDs is empty, return seek.empty tagged file. I mean, I could just return these. You don't generally see returns that much in Scala because it's the last thing in the function that gets returned. but on occasions like this, it is easier to use return. If this was in a future, I'd have to use an if statement and make it so that the result of the future is the thing and not just use a return. But so anyway, so this we're gonna do a select, of course. Select, and we're gonna select the ID, name, and note. Super easy, right? And I'm gonna be using this business here as well. So, eep. So, tag can apply to multiple things here. So what we're really going to end up doing is building up a list of the tags and which rows they go to, or sorry, which tagged file they go to, and then we'll use some group bys and some maps in the Scala code. You make it all work. Excuse me. Getting tired. Okay. My Barks cream soda with strawberry is out, so water is. Okay. All right then. So, ID, name, and note. And of course, these things, we're going to give them a fully qualified name for parsing purposes. And we're also going to pull out the file tag name. So I'm just going to keep that there real quick. Oh, sorry. Tagable file ID. Yeah. So I don't care about that one, basically. I will care about it, but not yet. Okay. Select blah, 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 blah from. And we're pulling it from the file tags table joined with the name of that long ass table that we wrote. On the file tag ID equal to ID. So let's get a little bit more specific with it. Like that. Yeah, that's fine. So join file tags with that on that. Where? File tags to the ID in file IDs. And then .as, and we'll make a parser for this. Yeah. So let's just verify this real quick. Let's get some FQNs going on here. Table file ID. Blah 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 blah. Need a comma there. So that's what we want to select, and I just want to verify in. I always forget if anorm can actually do this or not, because I'm pretty sure it can, but I can't remember if it actually can. So you do SQL here. There it is. Where's the thing? I'm looking for the statement parser. I can't remember. Or interpolator. I think it's this. Yeah, returns that simple SQL, which you can call on to get that with name parameter. I want to say I can do it. Pretty sure. Pretty sure. Yeah. Yeah, this is one of those things that I always forget if it can do or cannot, or if I had to do it myself, but I think I can do that one at least. Anyway, I'm pretty sure that's like the only collection one it has to find. So, okay. As file tags with ID. With file ID star. I do like this song a lot. Okay, so now we need to find file tags and that's a string. No, that's an int. Okay. So let's go to let's call it a file tag parser. Oops, hey. Copy that. And now let's go ahead and define it. So private to our MySQL package, a row parser that can parse out a file tag. Now this one isn't that crazy, I don't think at all. So yoink, these three. Oops. These three. Let's just push them back. And get some multi-cursor action going on. Alright, so they are basically all strings except for the last one, which we know isn't actually that, but we'll let it sit for now. And of course the commas are going to be mean. Alright, and this is an option. Oops. Alright. And then we map this, and we have an ID, a name, and a note. Well, it's a maybe note, but you know. And that becomes a file tag. And of course, this is a UID. So from string, and then bam. And we see how far we can go. Alright, so 2 errors, not bad. Okay, apparently it's not going to enjoy that. Meanie face. Alright, and then the other one is found unit required seek because I'm not returning anything yet. So let's ignore the error real quick and let's just write the code here. So we're going to end up taking the file tags and grouping them by the file IDs. Is that right? Is that what I want to do? I don't think that's what I want to do, but it might be. Yeah, no, I think that's what I want to do. Yeah. And then what we're going to end up doing is taking the tagged file, we're going to map over them. And then tagged file.id, we'll just put that temporarily into a thing. And then tags y.b.get. And that's going to give me a sequence of tuples, which I would just take the first one out of, which will be all the tags for the file. Right, and then we will take the tagged file. Tag file, we'll copy it and we'll say, hey, here are your tags, buddy. Yep. And we'll call that. Good. Alright, let's figure out this thing though. Ah, man. Found. String int required name parameter. You know, could have sworn I could do this. A norm, where in SQL. Yeah, this thing. 99% sure I've looked at this before. What? What? Is it, did I mess up somewhere? Is it because it's not a seek? What? Oh, it has to be a symbol. Is that really it? Is that really it? Doesn't seem like something that would actually work. Yeah, no. Am I crazy? Since 2.3, which should be the version I'm using. Oh, they've turned theirs into strings. Of course, the link doesn't actually work. Multi-value support. Hi, how you doing? Looks a lot like it wants it to be dumb. Alright, so let's just try this then, I guess. Is it really? No. What the heck? I'm not following you, buddy. Is it because it's a seek? What? Where categories? On categories, these things, or exit. Jeez, I mean that's complicated and neat and all. Cool that it does that, but that is not what I actually need. That is not quite it. Yeah, no. I've used this size code here before. Maybe that's why I think that I should be able to do it, because I used that helper before. It just seems like such an odd thing, you know? Just an odd thing. Alright, well, you know what? We're just gonna call it good. Here you go. Now what's your problem? Okay. We'll add it to do. Okay. Excuse me. Did I miss something here? Let's see. Blah, blah, blah. Okay. Could you just map that real quick for me? Bio tag to file ID. Just be a tuple for me, please. Just to make my life easier, if you don't mind. 2 errors. Okay, 172. Yank. Alright, where's my business? Files tagged. I asked it to group by number 2. Right? Yep. And then for each of these, get that. The group by, ask it for that. And then it's telling me that that is not a member. Oh, good. Oh, derp. That map. Where's the error? What? Okay, hold on. So if it's empty, it's empty. Such is life. Sorry, that's file tag. Because it's a map.get returns an option, because it may or may not exist. But if it does exist, then I would like the first thing, which should be a list. Pretty sure. I'm not totally understanding you here. Value underscore 1 is not a member of list on line 174. Right. Please and thank you. Nope. Found. List that required a vector. Womp womp. Is there a 2 vector? I feel like there is. There we go. And now let's look at this deprecation warning and see if I should fix it or not. Let's see. Excuse me? Oh, it's talking about postfix stuff. Yeah. I put parentheses around it to add the dot in to avoid the warning. There we go. And theoretically that should work. So there we go. Technically we could have done a join and a join there and pulled it out one by one and then aggregated each tag together. That would have been fine. Except for the limit part. See the limit of the offset here. If you're doing a join that is that's something that's not one-to-one with you, then you need to do a subquery there, and then you have to do the join in order to get back everything. So it's a little bit easier. And since we're planning on having this be a vaguely desktop application, it doesn't really hurt me to do 2 network calls essentially. So there we go. That's that. And unfortunately, until I write my until I get MySQL installed on this computer, which I wasn't really planning on doing, but I guess I will. I can't write the tests for it because the tests are going to go against the live test database. So that's that. But that's some code, and we haven't committed anything at all because we're terrible human beings. So you can see we have plenty of things to deal with. So we're going to add in flyway SPT. And let's look at our changes to the build here. We'll be editing this, but for the moment we'll leave it be, I guess. No. I don't want this anymore, which means I don't want that anymore. I probably don't even want this anymore. I need to find oh wait, no, I do want it. Okay, so that's fine. There we go. Are there any other things? Got status? Excuse me. Yeah, right. Let's add these driver bits, and they're a little bit wrong. So we'll need to correct the JDBC URL. Yep. So let's do that. And we'll just snag it from our other project. That's really the easiest thing to do. So in the conf we go, application.conf, and it's this. So application. We'll just call it like that. And then in here, I believe I have the driver right there. So I'll call that a day. Pretty sure actually the build, sorry, not the build, the flyway. Good song. Really, I should just use this, that. There we go. And yeah, we'll of course need to make a user password thing, so we'll do it once we actually install MySQL and have to mess with it. Whoops. So here we go. Let's do a little more. Not that. Not that. Yes, that. And yes, that. Okay, so this one we have added flyway configuration and DB dependencies for now. And then on top of that, we have this ID business. So say update abstract. I keep reading it off super tab. Abstract file with ID fields for subclasses. Can't have the ID. Depend on hash codes, since the ID would change. When we adding in file tags and other such junk. Why didn't I think of that before? Because I was just looking for a simple way to get an ID. Okay. And then we're not going to commit that, but we will. Oops. We should have included the play plugins part. Use Hikari CP play plugin, which is nice. And now we'll add the migrations in. Add initial database migrations for all our domain models. It's a sweet song. Alright, and then lastly, add in the DAO. Add in file DAO and MySQL implementation of it. Okay, so we made those things now. They're great. We're so happy. The last thing to do for this, well, you know, besides make other DAOs, because we've only made the one for the files, is to inject it in the module. So in our app module here in this configure, we write find class of file DAO, which we'll need to import, to class of MySQL file DAO. And we will go ahead and import DAO and import DAO .mysql. And we'll run SBT real quick again. The other thing that we'll do is we could make this a singleton, but I don't think we need to. Just because the DB object is obviously a singleton, it's an object, so it's a singleton. So I don't really need to worry about that at all. And there's no real state going on in it. So yeah, nope, don't care. Okay, so this alone is enough to say that when one of our services requests that it has a file DAO, it will retrieve the one backed by MySQL. And that'll be that. Alright, find file DAO to MySQL implementation. Produce. Bam. Okay. And that's going to do it for today, actually. Normally, I would continue on with the other DAOs, one for file origin, one for file tag. But because I don't have MySQL installed, I don't want to go any further because I want to write the tests for this class first. And to do that, I need to have MySQL. So, yeah. And, I could write the tests, and then we would just never see them pass. But I rather just, do it as an iterative process when I with MySQL running and everything like that. So until I get MySQL installed, no more on the DAO. So by next Sunday, by the next programming stream, I will do my best to have MySQL installed, and will have made a decision on whether or not I'm just going to actually install MySQL and have it cluttering up my path, or install Docker and have that run, which I'm probably going to do. Yeah, I'm probably going to do that. Okay, so thank you for watching if you did. And yeah, see you next Sunday. Sunday.